Hi everyone, welcome back. In this video, we'll take a closer look at how to block incoming mDNS traffic on Windows. Multicast DNS is commonly used for local network discovery, but in many environments it isn't necessary and can increase network noise or unwanted device exposure. I'll walk you through how to safely block incoming mDNS requests using Windows Firewall, explain what mDNS does in the background, and show you how to stop your system from responding to these multicast queries without breaking normal network connectivity. By the end of this video, you'll have better control over local network discovery and a cleaner, more secure network setup. Before we move on, let's take a moment to explain what mDNS is and why it exists. mDNS, or Multicast DNS, is a way for devices on the same local network to find each other automatically. Instead of asking a regular DNS server, like your router or an internet DNS service, your computer sends a question to all nearby devices at once. This allows devices to discover each other without any manual setup. When mDNS is used, Windows 11 sends messages to a special local network address. On IPv4, this address is 224.0.0.251, and on IPv6, it uses FF02FB, both on UDP port 5353. These messages are link-local, meaning they are only visible inside your local network. Other devices on the same network listen for these mDNS messages. If a device matches the requested name or service, it responds directly. This allows devices to find each other automatically without using a traditional DNS server. All of this happens quietly in the background, without any user interaction, and it can occur even when you are not actively using device discovery features. mDNS is commonly used for everyday features like finding printers, smart TVs, media servers, and other nearby devices. It is also closely tied to names that end with .local. The .local domain is a special name used only inside a local network and is not resolved on the internet. When Windows tries to resolve something like printer.local, it uses mDNS to ask other devices on the same network which one owns that name. Windows 11 uses mDNS to make networking simple and automatic. As soon as you connect to a network, your system can discover and communicate with compatible devices without needing IP addresses or manual configuration. While this is helpful for home networks, it also means your PC may be sending and listening for mDNS traffic even when you are not actively using these features. For some users, this behavior can be a concern. From a privacy perspective, your computer is announcing its presence and services on the local network. From a security or enterprise standpoint, mDNS and .local discovery may be unnecessary or even unwanted. Advanced users may also prefer to limit any background network communication they don't explicitly need. An important thing to understand is that mDNS and .local traffic are link-local only, they do not go out to the internet. This traffic uses multicast and is not controlled by a single Windows setting or service. Because of this design, disabling one option or service often does not fully stop mDNS or .local activity. This is why verification is important. Many guides claim that mDNS is disabled after changing a setting, but Windows may still send or receive mDNS and .local traffic in the background. Now that you understand what mDNS is, let's first verify that it's actually active on your system. A simple way to do this is by checking whether your computer responds to mDNS queries and advertises its hostname on the local network. This helps confirm that mDNS is running before we block it, so you can clearly see the difference afterward. To get started, click the Start menu, type PowerShell, then click Run as administrator. We need administrative privileges because we'll be creating firewall rules, and Windows requires elevated permissions for that. In the PowerShell window, type hostname and press Enter. Windows will display your computer's hostname, which is the base name your system uses to identify itself on the local network. Your mDNS hostname is simply your computer name with .local appended to it. For example, on my PC the hostname returned is desktop E770LG0, so the corresponding mDNS name becomes desktop E770LG0.local. This is the hostname my computer advertises over mDNS and uses to respond to name resolution requests on the local network. Next, let's test mDNS from another computer on the same local network. This helps confirm that your system is currently responding to mDNS requests before we block them. On the second computer, click Start, type PowerShell, and press Enter. There's no need to run it as administrator for this test. In the PowerShell window, Type Resolve-DnsName followed by the hostname of the first computer, then press enter. You can include the .local suffix, or try it without first. If mDNS is working correctly, the output will clearly show the .local hostname. If the result does not show the .local hostname, run the command again and explicitly include the .local suffix. This helps confirm that the name resolution is coming from mDNS, not from traditional DNS, LLMNR, or NetBIOS. Now that we've confirmed mDNS is working, we can move on to blocking it using Windows Firewall. Go back to the first computer, where PowerShell is already open as administrator. We'll create a firewall rule that blocks incoming mDNS traffic, which uses UDP port 5353 and a multicast address. By blocking this traffic, we prevent the system from responding to mDNS queries from other devices on the network. The command starts with newnet firewall rule. This command is used to create a new firewall rule in Windows. Then, we use displayName parameter followed by block incoming mDNS traffic. The displayName parameter is used to give a name to the firewall rule. By giving it a name like block incoming mDNS traffic, you instantly know that this rule is meant to block mDNS traffic. Then, we use the direction parameter followed by inbound. The direction parameter is used to tell Windows which way the rule should apply, whether it affects traffic coming into your computer or traffic going out from your computer. When you set inbound, the rule applies to incoming traffic, meaning anything that other devices on the network try to send to your computer. We then use the action parameter followed by block. The action parameter is used to tell Windows what to do with the traffic that matches the rule. By using block, we're telling Windows to completely deny the traffic. Any packet that matches this rule will be dropped immediately. The system does not allow it to pass through, and it will never reach applications or services on your computer. After that, we use the profile parameter followed by any. The profile parameter is used to tell Windows which network types the firewall rule should apply to. Windows separates networks into different profiles, and each profile can have different firewall settings. The main profiles are private, public, and domain. Private is used for trusted networks, like your home Wi-Fi. Public is used for untrusted networks, such as coffee shop Wi-Fi, airport hotspots, or other networks where you don't know. Domain is used when your computer is connected to a corporate or school network. By setting the profile to any, the rule will apply to all network types, ensuring that mDNS traffic is blocked whether you're at home, in a public place, or on a work or school network. Then, we use protocol parameter followed by UDP. The protocol parameter is used to tell Windows which network protocol the firewall rule should apply to. By specifying UDP, we are telling Windows to apply this rule only to UDP traffic. UDP stands for User Datagram Protocol, and it is a connectionless protocol. Unlike TCP, which establishes a connection and checks that data is received correctly, UDP simply sends packets without waiting for acknowledgement. This makes it fast and lightweight, which is why many discovery services like mDNS use it. After that, we use local port parameter followed by 5353. The local port parameter is used to tell Windows which port on your own computer the firewall rule should apply to. By specifying 5353, we're telling Windows to apply this rule only to traffic targeting that specific port. Port 5353 is the standard port used by mDNS. Whenever Windows sends or receives mDNS traffic, it uses UDP port 5353 on the local machine. Next, we use remote port parameter followed by any. The remote port parameter is used to tell Windows which port is being used by the other device on the network. In other words, the source port on the remote computer that is sending traffic to your computer. By setting remote port to any, we make sure all incoming mDNS packets are blocked, regardless of where they originate from. This is important because mDNS responses do not always come from port 5353. While mDNS listens on local port 5353, the sending device may use a random, high-numbered UDP port as its source port when replying. Next, we use the local address parameter followed by any. The local address parameter is used to tell Windows which IP address on your own computer the firewall rule should apply to. By using any, the rule applies to all IP addresses assigned to your computer. That includes IPv4 addresses, IPv6 addresses, loopback addresses, and any additional addresses your system may have. Finally, we use the remote address parameter followed by any. The remote address parameter is used to tell Windows which IP addresses the traffic is coming from on the other side of the network. In other words, it defines the source address of incoming packets. By using any, the rule applies to all address types, including both IPv4 and IPv6. Whether the packet comes from a multicast address, a unicast address, or a link local address, the firewall rule will still match. It also doesn't matter which device sends the traffic. The packet could come from another PC, a printer, a phone, a smart TV, or any other device on the local network, and the rule will apply the same way. Go back to the second computer and open PowerShell the same way as before. Use the same Resolve-DnsName command with the .local hostname of the first machine, or the hostname without .local if it was previously resolved using mDNS, and then press enter. This time, you should no longer receive a response. The name resolution should fail or time out, which indicates that the first computer is no longer responding to incoming mDNS requests. This confirms that the firewall rule is working as intended and that incoming mDNS traffic is successfully blocked. At this point, your system is no longer responding to incoming mDNS queries on the local network, but it may still be advertising its presence using mDNS. This happens because outbound mDNS traffic is still allowed. To completely stop mDNS behavior, including advertisements, you also need to create an outbound firewall rule to block mDNS traffic. Blocking outbound UDP port 5353 ensures that your system neither responds to nor advertises itself via mDNS on the local network. In the next video, I'll show you exactly how to create that outbound firewall rule, so you can fully disable mDNS. And that's it. Incoming mDNS traffic is now blocked, and your PC will no longer respond to .local discovery requests on the network. If this video helped you, feel free to like and subscribe for more tutorials. Thanks for watching, and I'll see you in the next tutorial.